In our last video of gateway redundancy, we're going to talk about GLBP, which is the Gateway Load Balancing Protocol, which is going to be another one of Cisco's proprietary implementations. And I'm going to give you the overview of how it works, give you a kind of draw it out, and then I'm going to implement GLBP and kind of guide you through why it does what it does. And it's kind of a pain, in my opinion. It works really, really well, but the term load balancing just means it's going to allow multiple routers that have multiple exit points to respond for all internal traffic. So rather than having one router doing all the forwarding while another router just sits there, it's like a high availability situation where GLBP steps in and allows every router that's got the capability of forwarding traffic out to the internet and receiving traffic in from the internet is going to be able to forward traffic. So you're not going to just be limited down to one device being able to forward. So it is Cisco proprietary, and it does use UDP multicast 224.0.0.102 at port 3222. It provides load balancing. It gives you one virtual IP address and multiple virtual MAC addresses. That's how it's able to utilize multiple addresses. It responds, it has a active virtual gateway, and this is where it gets kind of complicated and complex. So this is where I'm actually going to step in and start explaining some things and drawing it out. So it uses active virtual gateway, responds with virtual MAC addresses, responds with the MAC address for the active virtual forwarder, where the AVF is actually doing the forwarding. So you have the AVF handles particular virtual MAC addresses. AVFs back up each other, and AVFs have weights assigned. So ARP apply based on weighting. So by default, if we had GLBP configured on router 1 and 4 respectively, what will end up happening is, what's going to end up happening is, if this guy is the AVG and this guy is also the AVF, what will end up happening is just router 1 will be used. It's not until you actually turn on load balancing with the keyword load balance and give it a weighting. So you have to by default, the load balancing method it uses is round robin. So excuse me, if you want to change that, you have to go in and tell it load balancing is going to be weighting, and then you have to give each device a particular weighting value in order for it to do just that, to fail over. So it's the AVG is selected based on a priority. By default, AVG is the only AVF. All others are backup. It's replaced the our backup, and no AVG preemption by default. So you have to actually turn it on, enabled by using GLBP preempt. To enable load balancing, you would type in GLBP, the number, and then load balancing weighted. Then you can assign weights with the GLBP weighting and then the value. Weights can be assigned based on object tracking, so you can track an object and do that. So what we're going to do is I'm actually going to minimize this, and I'm not going to even pretend to know how to do this. So it's very similar to HSRP and VRP. I'm going to use this as my guideline because the commands are right here. It makes more sense to follow along with this than it is to do anything else. So what I'm actually going to do is I'll slide this guy up, and I'm going to pull router 1 over here, router 4, bring him down, and I'm going to pull router 2. Because router 2 is pretty busy too. So I'm going to do this. I'm going to scroll this guy over. So now what we're going to do on these guys is we're going to go to interface fast Ethernet 0/0. We're going to type in no VRRP 1. Same thing over here. Interface fast Ethernet 0/0, no VRRP 1. So that turns it off. What I'm going to do now is I'm going to, on this guy, is I'm going to do is GLBP 1, GLBP GLBP1 IP is going to be 10.100.14.254. I'm going to type in the timers are going to be, the only reason I'm copying this config verbatim is because the fact of it's a little more complicated than the other two, but it's once you get it configured, because you're going to be using multiple devices, so once you get the config in there and you can see how it works, I think it'll make more sense. So GLBP1 timers, it does by default, I don't remember what it does by default, to be honest with you. I don't remember. So we're going to do timers. It says millisecond and 333 and 1. And then we're going to do GLBP preempt. BP preempt. Oh, GLBP1. Sorry. I'm like, what the heck? 1 preempt. And then what I'm going to do here is GLBP 1 waiting. And then we have maximum waiting maximum value. We have is going to be 2. The reason why, now if you notice right here on this guy it's 2, this guy here it's 1. If we come back to this guy and we come back up to, this is the solutions, click on here, it says here to R1 should be the preferred gateway over R4 in a ratio of 2 to 1. So that's where waiting 2 to 1. So pull R1, pull R2, pull R4, and then waiting is 2. Then we're going to type in GLBP 1 load balancing is going to be weighted. By default it's round robin. And then what I'm going to do is GLBP 1, and it's going to be authentication is going to be MD5, and the key string is going to be DBM GLBP, because obviously it would be HSRP, but we're going to use GLBP instead. Next thing we're going to do is, and there's a lot of this is repetitive, very repetitive. So I would recommend, because the timers are almost identical and the weighting's almost identical, I would recommend just going in and copying this and going from there. So what I'm going to do is, when I get done with this, I'm just going to copy this to R4 and be done with it. I don't know if this is going to be something you can do in the exam, if they even have you test this, because you can only do this on routers. This is not available on switches. So we're going to type in GLBP1, and we're going to use waiting. Waiting is going to be track. Oh, we have the forwarder is going to be preempt delay is going to be minimum 0, and then I have to exit out of here and go to track 10 interface serial 0/0, and we're going to say line protocol, and then we'll be able to do that now. And we're going to exit out of here, and actually since I'm right here, I'm going to do that exit out real quick and do that to here, just because it makes it easier down the road. So that's what we're going to do here, and then we're going to jump back over to GLBP interface fast Ethernet 0/0, type in GLBP 1 waiting is going to be track 10 decrement 2. So there we have it. So we're going to do show run interface fast Ethernet 0/0. And like I said, we're just going to copy this config over, and I'm actually going to pull up this guy, and what I'm going to do is I'm just going to copy this information over and paste it, and then what I'm actually going to do is I'm just going to modify some of these numbers real quick. And just like that, interface fast Ethernet 0/0, and right click. There we go. And now we should be good to go. Now if we do, let's see now, what is the, I'm going to come back over here and it says, if R1's linked to ISP1, ISP1 down is down, it should not be used for forwarding. If R4 is linked to ISP2 is down, it should not be used for forwarding. Preemption should occur immediately if the other neighbor is down. All other design specifications should remain the same. So what I'm going to do is I'm going to go to R2 and I'm going to do this, bring this guy down and bring up R1 and R4 respectively up to here. Because I'm just curious to see what the load balancing looks like from the end user. So I'm going to do a extended ping to 3.3.3.3. Yeah. So we're going to repeat this 100 times, and I don't think it's going to make it much of a difference because at this point it's just going to be load balancing. Oh, we don't even have active. Show IP route. Interesting. Ping 10.100.14.254. Nope, can't do that either. Let's see. Same IP address. Show GLBP. Let's see here. Show ARP. 5E. Oh, I see why. He hasn't aged it out. Let's clear ARP. And try this one more time. So we're going to try to ping. Because we have two different, he's not learning it. Show ARP. Yeah, he's not learning the, this right here is the BRRP MAC address, and the GLBP MAC address is not being learned, which is this guy right here. Show GLBP. He is not learning it. So there are two forwarders, one active. Forwarder 1 state is listen. This guy is supposed to be responding for it. So, oh, I'm sorry. This is the MAC address. This is the MAC address right here. I'm sorry. This is the MAC address. This is the default. This guy should be the backup. He's not learning it. Let's here clear MAC address table and clear ARP. Let's see if R6 has learned it. Should have. There's R6. R6 has got an R6 still has an issue on fast season at 0/0. So we're gonna do config t interface fast season at 0/0. Speed 100 duplex. Speed is 100. Duplex is full. And that should bring that interface up. And we're going to show ARP. So we're going to ping 10.100.14.254. Alright, we can ping it. And we do a show ARP. The correct address is there. So he's going to router 1 and do show ARP. He too can do it and show ARP. He is okay. So they're load balancing. Beautiful. That's exactly what we were looking for. So let's scroll these guys over. Let's compare notes real quick. We have router 6 is using 0007 B400 0101. This guy's using all those except for he's using 02. So they're both being learned. Let's do show GLBP. One active. State is listen. This is for the I think this is the failover aspect of it. So they're both they're both being utilized. So if we were to do a trace to 3.3.3.3, we were going to router 4 and do a trace to 3.3.3.3. We're going to router 1 and then on to the final destination. So that's good. That's exactly what we're looking for. So we are load balancing, and the one way you can do that is by checking the MAC address. The MAC address table is going to be how you are able to verify what's going on. So that's it. I mean, that's pretty much GLBP in a nutshell. I just wanted to see if both routers were going to work. If you don't enable load balancing with weighted, what's going to end up happening is it's going to use just one device to respond to ARP requests, and it's going to do it in a round-robin fashion. I don't exactly know how that works, what the timeout values are, or if it's how often it goes from one device to the other. I prefer weighted because then you know both devices are going to be utilized at the same time. So beyond that, that is pretty much it for GLBP. I would recommend using the CCNP switch exam and the layer 2 technologies videos that I recorded for in-depth learning on how this stuff works if you want to know more about it. And this is use the lab exam prep, the walkthroughs and the labs in case you want to do more. I hope this has been informative for you. I want to thank you for viewing.